Welcome back to the Quarterly Call. All content is for informational purposes and is not investment advice. Please consult with an investment professional. So we are looking at just a monumental stack of material today.
It's a lot to get through.
It really is. And, if you feel like the world of technology is moving fast, what we've synthesized here, it suggests the pace has just jumped to a completely different dimension.
Right.
We're not talking about, simple incremental updates anymore. We're watching the very foundation of the cloud. What used to be just flexible servers and storage, it's rapidly becoming this era of highly specialized, purpose-built AI infrastructure and genuinely autonomous agents. The speed is just breathtaking.
It is an immense volume of innovation.
Yeah.
And the underlying financial scale, it completely validates that narrative.
Okay.
To give you some context on the scope of the business we're looking at,
Right.
AWS is now a staggering $132 billion annual business.
Wow.
And what's arguably even more compelling is that it accelerated its growth rate to 20% year over year.
So it's not slowing down.
Not at all. That trajectory suggests there's no slowdown in demand for those foundational services, even as the focus pivots, very sharply toward generative AI.
I think we have to just pause on that number for a second. 132 billion. It's so large, it almost loses its meaning unless you put it in perspective. Can you help us sort of conceptualize what that 20% acceleration actually means?
Absolutely. Let's just look at the absolute growth. In the last year alone, that was roughly $22 billion in additional revenue.
22 billion.
Think about that. That single year of growth, just the amount the business expanded, is bigger than the entire annual revenue of more than half of the Fortune 500 companies.
It's incredible.
We're talking about adding an incremental business that's larger than major established global corporations. This isn't just, some tech trend on the side. This is the bedrock of global enterprise.
Yeah.
And it's speeding up.
But that kind of scale, it must bring just immense complexity, right? We hear about the growth and all these new features, but does the material say anything about managing that? Are these new tools simplifying things for people or just adding more to an already overwhelming toolbox?
That's the central tension, I think, and that's what we're going to explore. The focus has really shifted toward integrating and controlling that complexity. So our mission here, as we look through all this, is to cut through the noise and explore the really impactful announcements.
Okay.
We've identified sort of three key areas that address both scale and complexity. First is the planet-scale infrastructure and the custom silicon that's powering all this.
Right, hardware.
Second, the big inflection point of AI agents and all the controls you need to deploy them safely. And third, the really specialized agentic tools that are just fundamentally changing how business gets done, especially in software development.
And we don't even have to look at the new AI stuff to see the scale. I mean, just look at the core established services.
Right. You look at something like S3. The storage offering has been around for almost 2 decades. The numbers, they're hard to comprehend. It now stores over 500 trillion objects.
Trillion.
And it handles 200 million requests every single second.
Wow.
And then on the AI side, Bedrock, which is the gateway for customers to use all these large language models, it's already powering AI inference for over 100,000 companies.
So this has moved way past the experimental phase.
Absolutely. It's deeply embedded in production workflows globally.
Okay, let's unpack this shift then. Let's start at the very foundation. The physical infrastructure, the actual metal you need to handle AI at this scale.
Exactly.
Yeah.
When you talk about training the next generation of models or running these massive inference jobs, you're talking about computational needs that demand a just and unmatched physical presence, both in geography and in raw power.
And the global footprint they're managing is just astounding. Physically, the network spans 38 geographic regions, 120 availability zones, and they've already announced plans for 3 new regions. But the raw physical scale in terms of power, that might be the most surprising number. In just the last year, they added 3.8 gigawatts of data center capacity.
And that number isn't just a big figure, It sets a new global benchmark. 3.8 gigawatts is more data center capacity than any other provider added in a single year, globally.
And that's all for AI.
That level of investment is directly tied to anticipating the massive sustained power needs of these AI training clusters.
And then you have to tie all that capacity together. You have to make sure data can move synchronously across continents. That's what they call their private network, right? This isn't the public internet.
Precisely. It's a specialized, dedicated, high-speed optical fabric. And this private network, its physical scope increased by 50% in just the last 12 months.
50%.
It's now more than 9 million kilometers of cable, which tells you that modern AI training, it's fundamentally decoupled from the bottlenecks of the public internet.
9 million kilometers of cable.
Very
It's
clear.
hard to visualize that. What does that actually represent?
It's enough optical cabling to reach from the Earth to the Moon and back again over 11 times.
Wow. Okay.
And that level of investment, it underscores a critical point for you, the listener. AI workloads are incredibly bandwidth intensive. To train a model reliably, you need hundreds of thousands of chips communicating almost simultaneously.
Right.
And that requires this kind of proprietary network to bypass congestion and latency. It's an enabling technology.
That makes perfect sense. And when we talk about running those massive jobs, the conversation always turns to the specialized hardware, the GPUs, the custom silicon. And the sources really emphasize the intense operational rigor you need to run these clusters reliably.
And what's fascinating is the operational history they bring to this. They've had this long-standing collaboration with NVIDIA. They were the first to offer NVIDIA GPUs in cloud over 15 years ago.
Great.
So this deep history means they've learned how to operate these large GPU clusters at scale better than anyone. They even say that other providers often just accept minor hardware hiccups as, the cost of doing business.
Whereas AWS is trying to prevent them entirely.
Exactly. They focus intensely on preventing downtime. And downtime is measured in massive dollar losses when you have a cluster of thousands of GPUs running a training job that might take a week or more.
So even a small glitch can ruin everything.
Precisely. They talk about sweating the small details, like debugging low-level BIOS or firmware issues, just to prevent a single GPU from rebooting. Because even a tiny downtime event can derail a massive multi-day job, forcing you to restart the whole process. That's millions of dollars in compute time wasted.
And that operational reliability is their core differentiator.
It is. Even as they introduce the newest hardware, they're bringing in the new P6e GB300 instances, which are powered by NVIDIA's latest GB300 systems. These are designed for the most demanding AI workloads, basically operating as one massive supercomputer.
And it seems like the industry leaders agree. It's not just startups using this.
No, it's validated by the ecosystem leaders themselves. OpenAI is actively running their applications on AWS, using these ultra-server clusters for ChatGPT and for training the next-gen models.
Okay.
And even NVIDIA, who obviously has their own hardware expertise, runs their big Gen AI cluster project called SIBA on AWS. That's a huge external stamp of approval for the operational reliability.
But the strategy isn't just about NVIDIA. It's clearly about choice and price performance, which means they are aggressively accelerating their own custom silicon. And that brings us to their in-house chips.
Graviton has been the big success story on the general compute side for a while now, but in the AI space, the custom chip is Trainium. And it's already grown into a multi-billion-dollar business.
And here's where the story gets really interesting, because the name itself is a little misleading, right? It was called Trainium because it was designed for training, but what's the reality of how it's being used?
The big surprise, and the material highlights this, is that Trainium 2 is now seen as a leading system in the world for inference, not just training.
For inference, so running the models, not just building them.
Exactly. It's a crucial pivot. The majority of the generative AI inference happening in Amazon Bedrock today is already powered by Trainium. If you're using models like the latest from Claude in Bedrock, that traffic is running on Trainium because it delivers the best end-to-end response times.
How many have they deployed?
They've already deployed over 1 million Trainium chips, ramping up volume 4 times faster than their next fastest AI chip.
A chip designed for training that's now excelling at inference.
Yeah.
That's a huge efficiency win. You can use the same silicon for 2 very distinct stages of the AI lifecycle, and now they're pushing it even further with the general availability of Trainium 3.
Trainium 3 is a monumental leap. These new Ultra servers feature the industry's first 3-nanometer AI chip deployed in the cloud.
Okay, so why does 3 nanometer matter to the listener? What does that translate to?
3 nanometer refers to the manufacturing process, how densely packed the transistors are. A smaller number means higher density, which translates directly into massive gains in speed and, critically, in power efficiency.
And what are the performance metrics on that?
We're talking about a 4.4 times jump in raw compute performance and 3.9 times more memory bandwidth than the last generation.
But I imagine the most important metric for the business might actually be the efficiency number.
Absolutely. For sustainable, planet-scale AI, efficiency is everything. And Trainium 3 delivers 5 times more AI tokens processed per megawatt of power consumed.
5 times.
When you're deploying hundreds of thousands of these chips for continuous training and inference, that 5x efficiency gain translates directly into significantly lower operational costs. It makes frontier AI affordable for more companies.
And these Trainium 3 Ultra servers are designed to combine, what, 144 chips together?
A staggering 144 chips acting together in a single, unified scale-up domain.
Help us conceptualize what that actually means for someone trying to train a new frontier model.
It means you're eliminating bottlenecks that plague traditional supercomputers. In a scale-up domain, all 144 of those chips are essentially acting as one giant coherent processing unit.
So they all talk to each other instantly.
Exactly. They're connected by custom neuron switches and use AWS's high-speed custom networking, EFA, which is designed for this kind of low-latency, high-bandwidth communication. This unified design delivers 362 FP8 petaflops of compute in a single instance.
And a petaflop is a measure of?
Floating point operations per second.
Yeah.
Basically, how many calculations the machine can do. That massive collective power ensures that a customer can keep all the processing units saturated with data and synchronized across the entire job. It requires optimization at every single layer.
And just to show how relentlessly fast this is moving, the material already teases the next generation, Trainium 4.
They're not slowing down. Trainium 4 is already deep in the design phase. It promises another massive leap over T3, with 6 times the FT4 compute performance and 4 times more memory bandwidth. The strategic importance of custom silicon is just crystal clear.
Before we move on from infrastructure, we have to touch on this offering for the most regulated customers, AWS AI factories. This seems to move the cloud closer to the customer's own data center than ever before.
It is a critical offering. It's aimed squarely at meeting those stringent compliance, regulatory, and data sovereignty requirements. AI factories let customers deploy dedicated AWS AI infrastructure, the latest Trainium or NVIDIA GPUs, access to Bedrock, but within their own data centers.
So it's like a private AWS region just for their AI.
That's a great way to think about it. The customer uses their existing space and power, but they get the exact same state-of-the-art AI stack. And that ensures the data never leaves their physical control, while they still get to benefit from the innovation cycle of the public cloud.
Okay, so moving from the metal to the mindset, let's talk about this agentic inflection point. This is really the shift from, a technical wonder to practical business value. We're moving past AI assistants that just answer questions and into true AI agents that can autonomously perform complex multi-step tasks for you.
This transition is profoundly important. The suggestion is that this shift to pervasive autonomy will have as much impact on business as the internet or the cloud did.
Really? That big of a shift?
The belief, based on the material, is that billions of agents will soon exist inside every company, acting as specialized high-velocity workers. They'll accelerate drug discovery, transform customer service, and just scale human impact by an order of magnitude.
But to handle that kind of scale, billions of autonomous workers accessing sensitive data, you need a secure foundation. That's why Bedrock Agent Core was introduced, and its adoption seems to be taking off, with the SDK downloaded over 2 million times already.
Agent Core is essentially the operating system for deploying these agents securely at enterprise scale.
Yeah.
It's comprehensive, it's modular, and it provides all the non-AI infrastructure an agent needs to be effective and safe.
What are the core components?
It handles all the logistics: a secure serverless runtime for session isolation, memory to manage both short-term context and long-term learning, a gateway for discovering tools and data, identity for authentication, and observability for real-time visibility.
And critically, it's designed to be open, right? You can use it with other frameworks like LangChain and with any model, whether it's on Bedrock or external ones like GPT or Gemini.
Yes, that flexibility is crucial. But here's the core challenge that the sources highlight. Agents are powerful because they're autonomous. They're non-deterministic. They write their own code, they determine their own steps, and that makes them highly unpredictable.
Which introduces a massive amount of risk if it's left unchecked.
Exactly. You need external guardrails to control that unpredictable behavior, especially when they're accessing your sensitive enterprise systems. It's like balancing freedom with responsibility.
If you give an agent the keys to your financial systems or your customer data, you have to be absolutely sure it won't do something catastrophic.
That is precisely the challenge that Policy, a new feature in Agent Core, is designed to solve. It provides real-time deterministic controls over how agents interact with sensitive tools and data, whether that's internal APIs, Lambda functions, or services like Salesforce or Slack. The policy layer is the external gatekeeper.
Policy sounds critical, but how do you avoid just replacing code writing with an equally complex process of policy writing?
That's the elegant part of the design. These policies are defined at a high level and then converted into the open source Cedar language, which is built for microsecond evaluation. And crucially, these policies are evaluated in milliseconds by the policy gateway before the agent ever gets access to the tool.
So the enforcement sits completely outside the agent's own logic.
Right. It's not relying on the agent to be safe. It ensures predictable compliance externally.
Give us the clearest example of that in action.
The example they used was financial control. Imagine an agent processing customer support tickets, which sometimes involves issuing refunds. You can define a policy that says, block all refunds from customers when the amount is greater than $1,000, unless there's specific managerial authorization.
Okay.
So if the autonomous agent tries to execute a refund API call for $1,500, the policy gateway instantly evaluates that Cedar rule and just denies the request, period, regardless of what the agent's logic tried to do.
So you can grant autonomy for 99% of tasks, knowing that critical 1% is protected.
That's it. It's what makes this scalable.
So policy defines the rules. But the other side of trust is verification, right? The whole trust but verify principle. That brings us to agent core evaluations.
Right. Traditional software testing is notoriously difficult for autonomous agents because the output isn't deterministic. You can't write a unit test expecting one specific answer. You have to judge quality based on complex criteria. Is it correct? Is it appropriate? Is it helpful? Is it on brand?
And measuring that used to require complex data pipelines and data scientists. It was slow and expensive.
And every time you swapped models or upgraded the agent's tools, you had to rebuild that whole measurement pipeline. Agent Core Evaluation simplifies this by continuously inspecting agent quality based on real-world behavior. It includes 13 pre-built evaluators for common things like hallucination, correctness, harmfulness.
And you can customize it.
Crucially, yes. It allows for custom scoring, so an enterprise can define exactly what on-brand customer interaction looks like for them. You can deploy an agent and continuously monitor its quality, catching subtle degradations quickly.
So that combination, policy for control and evaluation for quality assurance, is what finally unlocks safe, scalable enterprise deployment of these agents. And we have a great customer spotlight on this, Sony.
Sony's journey is fascinating. It shows a global legacy company really embracing this future, driven by their core concept of Kondo, creating deep emotional connections.
But they've been using AWS for a while, right?
For years, they used it for the PlayStation 5 launch, which let them accelerate microservices deployment by 400% with just 1/10 the lead time.
So the foundation of agility was already there. How did they transition that into agentic AI?
They started with an internal, homegrown enterprise LLM built on Bedrock to maximize employee productivity. That system is already serving 150,000 inference requests a day to over 57,000 users.
Wow.
And now they're integrating Bedrock Agent Core to govern and manage more complex agentic capabilities. They're applying model customization techniques, which we'll get into next, with the goal of increasing the efficiency of their compliance review processes by a factor of 100x.
100 times. That is the kind of material business value that autonomy is starting to deliver.
It is.
And that's a perfect lead-in to the model layer itself, because the agent's quality ultimately comes down to the model's knowledge and reasoning. Until now, brag and fine-tuning were the standard for customization.
Right. And RG is great for giving models current context at inference time. Fine-tuning is useful for steering a model's style or voice. But they both hit a wall when it comes to true domain mastery. The sources use a great analogy.
Okay.
It's really hard to teach a large language model completely new, deep domain knowledge like proprietary internal jargon or industry constraints without causing it to forget some of its core foundational reasoning.
It's like trying to learn a new, highly specialized language later in life versus when you were a child. The new knowledge sort of sits on top and can interfere with the foundation.
Exactly. Post-training customization tends to dilute the model's core reasoning. So the question becomes, what if you could integrate your proprietary data during the training process, making that new knowledge part of its core reasoning structure? And that's the revolutionary idea behind the new service, Nova Forge.
This sounds like a complete redefinition of how companies will own their AI models. How does it work?
Nova Forge introduces this idea of open training models. Instead of starting from scratch, which is impractical for almost any company, it gives customers exclusive access to Nova training checkpoints. So imagine starting with a model that's already 80% pre-trained.
Okay.
The customer can then securely blend their proprietary data, their IP, internal memos, domain expertise, together with the Amazon-curated dataset at every stage of the final training process.
So you're not just adding a thin layer of knowledge at the end or a document for it to reference. You're fundamentally teaching the model the unique contours of your business from its earliest formative stage.
Precisely. The outcome is a proprietary model they call a novella. And this novella deeply understands the customer's specific information and domain structure without sacrificing its powerful foundational reasoning. This allows for what they call novel domain reasoning.
Which means it can interpret complex, unique scenarios specific to that company's history. Let's expand on that hardware manufacturer example from the material.
Okay, so consider a manufacturer with gigabytes of proprietary data path designs, failure modes, review notes, manufacturing constraints. They use Forge, starting from an 80% pre-trained Nova 2 Lite checkpoint, and they blend all that proprietary data in.
Right.
Now, when their engineers ask a question like, given our historical thermal failure rates, what are the optimal cooling tolerances for design A versus B, they get responses that are specific to the company's internal constraints, historical success rates, even the personality of the reviewer who signed off on the original specs.
That's a level of integrated reasoning that RGA just cannot achieve.
That's a different ballgame.
And we saw a major real-world use case with Reddit.
Right. Reddit uses AI to moderate content across thousands of unique communities, each with its own rules and tone. They found fine-tuning generic models just didn't get them the accuracy or the cultural nuance they needed.
So what did they do?
By using Forge to integrate their proprietary data community guidelines, historical moderation decisions during pre-training, the resulting model developed these integrated representations that combine general language understanding with their specific community knowledge. It was the first time they could produce a model that met both their accuracy and their massive cost efficiency targets.
And speaking of Nova, there's a whole new family of models available on Bedrock Nova 2. Can you just quickly walk us through the hierarchy?
Sure, we can start with Nova 2 Lite. That's positioned as the fast, flexible, cost-effective workhorse, ideal for high-volume, repetitive tasks. It's highly competitive with models like GPT-5 Mini and Claude Haiku 4.5.
Okay, and then for the most complicated challenges.
For that, you have Nova 2 Pro. It's the most intelligent reasoning model, intended for highly complex, multi-step workloads. And critically, it really shines in the skills vital for agents' robust instruction following sophisticated tool use. In benchmarks focused on those specific skills, it delivered better results than leading models like GPT 5.1 and Gemini 3 Pro.
And then there are the specialized models, Nova 2 Sonic and Omni.
Nova 2 Sonic is their next-gen speech-to-speech model, all about enabling real-time, human-like conversational AI, reduced latency, expanded language support, making it feel more like a fluid conversation.
But the highlight model, Nova 2 Omni, sounds like it solves a major workflow problem by unifying all these different data types.
It absolutely does. Today's most complex tasks often require stitching multiple models together, one for an image, another for audio, a third for text. Nova 2 Omni is a unified model for multimodal reasoning and generation. It supports 4 input modalities, text, image, video, audio, and 2 output modalities, text and image generation. It solves that stitching problem.
So if I wanted to, say, summarize a major industry keynote speech.
A single Nova 2 Omni agent could ingest the video file, understand both the slides and the speaker's audio, synthesize all that information, and then generate a summary report complete with marketing images, all in one fluid step.
That drastically simplifies development.
It does.
Now, if we move from the models themselves to how they're being applied, we get to frontier agents. This seems to be the ultimate promise of productivity.
Right. Frontier agents are distinguished from what came before by 3 characteristics. First, they're autonomous, directed toward a broad, long-term goal. Second, they're massively scalable, able to perform multiple concurrent tasks. And third, they're long-running, working for hours or even days without constant human intervention.
The sources had an anecdote about an internal AWS project that just blew me away. The re-architecture story. It really drives home the productivity revolution these agents enable.
It's the most compelling metric about the future of software development I've seen. An internal team was planning a significant re-architecture. They initially projected needing a large team, 30 developers working for 18 months to complete it.
Okay, a big project.
By fully leveraging these new agentic tools, they completely shattered that projection. A much smaller team of only 6 people delivered the entire project in just 76 days.
Wait, stop and process that. A year and a half of work down to 2.5 months with 80% fewer people? That's not a 10 or 20% gain. That's a 10x velocity increase.
This is the future of productivity. But the key learning for you, the listener, is that achieving this didn't just happen by plugging in an agent. The human engineers had to fundamentally change how they worked.
So what does this tell a human engineer about how they need to change their workflow? What were the key lessons?
The first lesson was about the scope of instruction. They had to move away from feeding agents small, task-by-task instructions and shift to directing broad, goal-driven outcomes, like upgrade this library across all 15 microservices and ensure all error handling conforms to our new standard.
So the human's job shifts from execution to high-level strategy and quality assurance.
Exactly. The second lesson was realizing that velocity was tied to maximizing concurrency. They had to re-engineer their mental model to scale out parallel agentic workloads.
And the third lesson was about true autonomy.
The third was maximizing the long-running autonomous nature of the agents. They saw that progress stopped when the humans went home. So by enabling the agents to autonomously clear the backlog while the human team slept, the engineers would wake up to massive amounts of completed code ready for review.
That new philosophy directing goals, maximizing concurrency, and allowing autonomy led directly to the launch of these three core frontier agents, starting with the Kiro autonomous agent for building software.
Kiro transforms the developer backlog. A developer assigns a complex task like upgrading a critical library, and the agent independently plans, coordinates, and executes the changes.
The key advantage here, beyond just speed, seems to be the agent's memory, its ability to standardize quality.
That is the crucial differentiator. The Kiro agent doesn't just do the task once. It maintains context over the whole project. It learns how the team works. It builds a collective memory of the code base. So if a human makes a correction on a pull request, the agent applies that learning instantly and consistently to the next 14 related tasks.
Which you just can't do without accelerating the other parts of the life cycle. You'd just create new bottlenecks. This brings us to the AWS security agent.
Security has always been a primary bottleneck. Most companies just can't afford rigorous penetration testing for every minor release. The AWS security agent embeds security expertise upstream, shifting security left in the process.
How does that look in practice?
It proactively reviews design documents and scans code for vulnerabilities, integrating feedback directly into GitHub pull requests. But more revolutionary, it transforms that slow, expensive penetration testing into an on-demand, continuous practice. It continuously validates the application's security posture, and when it finds an issue, it provides validated findings with suggested remediation code for the developer to approve.
And finally, you need an agent for operations to run all that rapidly deployed code. This is the AWS DevOps agent, the 24/7 always-on call agent.
Operations can become overwhelming as systems scale. The DevOps agent is designed to investigate and resolve incidents autonomously. It learns from all your resources, runbooks, observability tools like Dynatrace, code repositories, CI/CD pipelines.
So when an alarm goes off at 3 a.m., it's already working on it.
Let's use an example. An alarm alerts for high authentication error rates on a critical Lambda function. The agent instantly traces the issue back through recent deployment history. It might discover the root cause was a subtle mistake in a recent CDK code deployment that changed an IAM policy.
A simple human error.
The agent identifies the exact source of the change, suggests the precise fix, and presents it to the on-call engineer for a one-click approval.
That's root cause analysis and immediate remediation. But the best part is the proactive element.
Exactly. Even better, it recommends specific CI/CD guardrails to prevent that specific policy mistake from ever being deployed again. It's a complete solution for incident response and continuous prevention.
Okay, we've covered the three massive pillars of AI innovation: the infrastructure, the control plane, and the frontier agents. But those agents need underlying infrastructure that can keep pace. So let's quickly review the fundamental shifts in the core services.
Right, this section confirms that innovation isn't slowing down in the traditional cloud services. In fact, the AI demands are driving accelerated innovation there.
So starting with compute, they're responding to memory-intensive and latency-sensitive workloads.
We saw the new X family of large memory instances, providing up to 50% more memory, powered by custom Intel Xeon 6 processors. For pure speed, we have the M8 ASIN instances.
Why does the absolute fastest CPU clock frequency matter for a business listener?
It matters intensely for latency-sensitive applications. High-frequency trading, real-time betting, massive multiplayer gaming, every nanosecond saved by that speed could translate to millions of dollars.
And crucially, we finally have Lambda durable functions. This is huge for developers building those long-running agentic workloads.
Yes. Until now, Lambda was for stateless, quick execution. With durable functions, developers can easily program wait times and manage complex state across workloads that might span hours or even days directly within Lambda. It solves a massive orchestration headache.
Moving to storage and data, S3 got a significant boost in scale and performance.
The maximum object size for S3 increased 10x, from 5 terabytes to 50 terabytes. This accommodates modern genomic data files, high-res video, large training checkpoints, and S3 batch operations is now 10 times faster.
And for customers with massive data lakes, there's an immediate automated efficiency update for Iceberg tables.
Intelligent tiering for S3 tables. It automatically monitors access patterns for Iceberg tables and moves less frequently accessed data to chopper storage tiers. This can save customers up to 80% on storage costs.
And finally, vectors, the core data structure for AI, are getting native support in S3. Why does storing vectors in S3 reduce cost and complexity?
This is a major structural shift. S3 vectors is now generally available. It lets customers store trillions of vectors in a single S3 bucket. It makes vectors a first-class citizen of cloud storage. It reduces the cost by 90%, and more importantly, it simplifies the data pipeline by eliminating the need to move massive amounts of data just to run a vector query. Let's finish this blitz with database and efficiency improvements. Legacy databases have capacity limits and prohibitive licensing costs. Right. The storage capacity for RDS for SQL Server and Oracle was quadrupled, from 64 terabytes to 256. This also delivers a 4x improvement in IOPS and bandwidth, making it much easier to migrate large on-prem workloads.
And on the cost side, they've provided a surgical way to cut Microsoft licensing fees.
Exactly. They introduced the ability to specify the exact number of vCPUs for a SQL Server instance. Since Microsoft licenses are tied to vCPUs, this gives customers granular control to reduce their licensing costs. And finally, the database savings plan.
A unified savings plan for databases, offering savings up to 35%. That's a massive simplification for customers.
So what does this all tell us? We've covered a profound structural leap forward. It's driven by relentless investment in custom silicon like Trainium, the creation of models that deeply integrate proprietary knowledge through NovaForge, and the deployment of control and governance tools like aging core policy and evaluations.
The ultimate theme here is the transition from managing complex infrastructure and tedious manual tasks to orchestrating genuinely autonomous workflows. The era of agents handling the repetitive bursts of the software lifecycle, the building, the securing, the operating, it isn't a future concept. It is operational today. It frees up immense human capacity and dramatically shifts where human value resides.
And this brings us to the ultimate relevance for you, the listener. If autonomous agents are taking over the building, securing, and operating of software, if we can achieve that 10x productivity boost, we have to ask, what is the new highest value activity for human engineers? When we liberate all that time and energy currently spent debugging IAM policies or applying security patches, where will we dedicate it? It means moving away from the tactical and into the truly strategic, the complex, ambiguous, and inventive problems that we currently consider impossible. That is the question you should be pondering as you absorb the implications of this shift.
Thank you so much for tuning into the Quarterly Call. For more episodes, please remember to rate and follow our show. Until next time, stay curious and stay informed.